Right now, somewhere off the coast of California, the ocean is doing something it has never done before. Not rarely, not once in a generation. Never, not once in the entire 75 years that scientists have been keeping careful, reliable records of ocean temperature. And the strange part is, most people have no idea it's happening. Last week, nearly 6,000 people logged onto a single online meeting to hear a handful of scientists explain, in plain language, what's building in the Pacific Ocean right now. Think about that for a second. 6,000 people did not tune in for a routine weather update. People don't rearrange their evening, open a laptop, and sit through an hour of scientific testimony because someone told them there's a 50% chance of rain in November. They showed up because word had already spread that something bigger than a normal forecast was happening, and they were right to show up because what federal scientists confirmed just days earlier was not a normal forecast at all. Here is the number that is quietly terrifying the people who study this for a living. On August 13, 2026, the Climate Prediction Center, the branch of NOAA responsible for the official United States government forecast, released an update stating that a so-called Super El Niño is now considered extremely likely to fully develop this year, and that there is roughly a 7 in 10 chance it becomes the single strongest El Niño ever measured since comprehensive record-keeping began in 1950. Read that again. Not one of the strongest, not comparable to. The strongest ever recorded, full stop, with the odds sitting at around 70%. And here's what makes that number so different from the usual seasonal chatter you might scroll past without a second thought. The scientist who leads NOAA's El Niño team, someone whose entire job is measuring ocean temperature swings and calmly explaining them to the public, used language this month that people in her position almost never use. She said, plainly, that the ocean temperatures now being recorded in the benchmark patch of the tropical Pacific that scientists use to define El Niño strength have never appeared in the historical record. Not during the massive 1982-83 event, not during 1997 and 98, the event that shaped how an entire generation of Californians thinks about winter storms, not even during the so-called Godzilla El Niño of 2015 and 16, still considered one of the most extreme ocean warming events ever measured. This year's number is on pace to beat all of them, and the person whose entire career is built around staying calm about ocean temperature swings is the one telling you that. So today, we're going to walk through exactly what's happening, why the scientists tracking this are more concerned than they've been in years, and specifically what it means for California this winter, because the impacts here are not abstract. They are measurable, they are already being modeled block by block along the coastline, and in some cases they are already showing up in the water right now, months before the first big winter storm even arrives. Before we get into the mechanics of it, it's worth asking why this particular update landed so differently than the dozens of routine seasonal outlooks that come and go almost every year, without anyone outside the weather community paying much attention. Forecasters issue updated seasonal outlooks constantly. Most of the time, the language stays fairly measured, likely above normal elevated risk. Careful, hedged, technical language that rarely makes it past the weather segment of the local news. This update was different, and it was different specifically because of who was saying it and how they were saying it. When the federal agency responsible for the official U.S. forecast has its own lead scientist using a phrase like never happened in our historical record about the single benchmark measurement the entire El Niño classification system is built around, that is a meaningfully different category of statement than the ones that scroll past most winters unnoticed. That's the detail that should make you sit up, not the word super attached to the front of it. Let's start with the actual science, because the phrase Super El Niño gets thrown around so casually that it's worth understanding what it technically means and why this year's version is different from anything researchers have on file. El Niño itself is not a storm. It's not even weather in the traditional sense. It's an ocean pattern, a periodic warming of a specific stretch of the tropical Pacific along the equator, roughly between South America and the international dateline. Scientists watch one particular patch of that ocean extremely closely, a benchmark region researchers refer to using a grid coordinate, and they use the temperature swing in that specific patch as the yardstick for how strong any given El Niño event is going to be. When that patch runs about 1.5 degrees Celsius above its normal seasonal temperature, you're looking at a strong El Niño. When it crosses roughly 2 degrees, you're in super territory, a genuinely rare classification that has only happened a handful of times in the entire modern record. This year, multiple independent forecasting groups, not just NOAA, but international models run by European and Japanese agencies as well, are now showing peak ocean temperatures in that benchmark region pushing toward 3 degrees Celsius above normal, and some ensemble forecasts are suggesting it could go even higher before the year is out. To put that in perspective, no El Niño event in the entire recorded history of that measurement, going back over a century, has ever meaningfully pushed past roughly 2 3/4 degrees. This year is on pace to challenge that ceiling outright. That's not an incremental update to last month's forecast. That's forecasters watching a number climb into territory nobody has ever actually observed and having to say so out loud. It's worth pausing here to understand why researchers are so specifically focused on this one number instead of just calling it a really strong El Niño and moving on. The reason is that the entire predictive relationship between El Niño and its downstream effects, rainfall, flooding, drought elsewhere in the world, storm intensity, has historically been built by studying past events and their outcomes. But when the measurement itself moves into a range that has literally never been observed before, scientists lose the ability to simply look up what happened last time, because there is no last time that matches this. That is precisely why researchers keep repeating the phrase uncharted territory instead of comparing this outright to 1997 or 2015. It isn't hedging. It's an honest admission that the historical playbook may not fully apply here. Now, it helps to understand just how rare a genuine super El Niño actually is, because every single one that has occurred in the modern era left a very distinct scar on California, and each one surprised scientists in a different way. The 1982-83 event was one of the first strong El Niños closely studied using early satellite monitoring, and it delivered severe flooding and storm damage across California that ran into the billions of dollars, along with dozens of deaths statewide. Then came 1997 and 98, still the reference point most Californians over a certain age remember most vividly. That winter brought such a relentless, sustained parade of Pacific storms that one NASA scientist, who ended up coining the nickname Godzilla El Niño for a later event, warned residents ahead of time that they'd essentially be kayaking in front of their own homes by January and February. That forecast proved accurate enough that the 1997 to 98 season alone is blamed for roughly 17 deaths and around $500 million in damage across the state. Then came 2015 and 2016, which was, at the time, one of the strongest El Niños ever measured purely in terms of raw ocean temperature. And this is the event scientists keep bringing up again and again right now, because it broke the pattern almost everyone expected. Despite ranking among the most extreme ocean warming events on record, it delivered nowhere near the rainfall that Northern California had been led to expect based on direct comparisons to 1997 and 98. People built sandbags, reservoir managers braced for historic inflows, and in large stretches of Northern California, the parade of atmospheric rivers many expected simply didn't fully show up the way the temperature numbers implied it should. That mismatch became one of the most important lessons in modern El Niño science, and it's exactly why researchers studying this year's record-breaking ocean temperatures are being careful not to treat them as an automatic guarantee of comparably extreme rainfall. More on that in a moment, because it matters enormously for how you should actually interpret everything else in this video. This is the exact backdrop that brought thousands of people to a virtual town hall organized by a California state senator in early August, an event specifically convened to help residents across Northern California, in his own words, separate the hype from the reality of what this winter might actually bring. The panel wasn't there to calm anyone down artificially, and it wasn't there to sell fear either. One of the climate scientists on that panel, a researcher who has spent years cataloging the state's floods, droughts, wildfires, and storms professionally, told the audience directly that the system now gathering strength in the Pacific could produce something California hasn't experienced in living memory. That is not a phrase a career climate researcher throws around lightly, and when someone with that specific depth of comparative experience says a developing pattern could exceed everything in living memory, that's worth taking seriously as an informed, sober assessment rather than dismissing it as hype. So why is this year fundamentally different from 1997 or 2015 in a way that goes beyond just the raw ocean temperature number? Here's the piece that a lot of casual coverage misses entirely, and it's arguably the single most important detail in this whole story. Every previous El Niño in the historical record developed on top of a cooler global baseline than the one the planet is sitting on right now. This year's event is forming on top of a planet where global ocean temperatures, independent of El Niño entirely, are already running warmer than at any point in recorded history. Scientists have never before observed a strong or very strong El Niño arriving on top of pre-existing global ocean conditions this warm. Because of that layering effect, researchers are warning that it wouldn't be surprising to see genuinely unprecedented global impacts later in 2026 and into 2027, spanning flooding, drought, and wildfire-related extremes happening simultaneously in different parts of the world. Some of the same scientists have gone further, suggesting there's a real chance that 2026, 2027, or both, end up setting new global temperature records, because the naturally occurring heat redistribution of El Niño is essentially riding directly on top of a climate system that was already running hotter than ever before it even started building. Now let's get specific about California, because the global framing, alarming as it is, doesn't tell you what actually shows up on your street, your beach, or your hillside this winter. The most immediate, most measurable impact that scientists have already quantified involves sea level, and understanding the actual mechanism here matters more than just memorizing the headline figure. El Niño doesn't only warm the surface of the Pacific. Warmer water physically takes up more space than cooler water, a basic property called thermal expansion. At the same time, the weaker trade winds that come with El Niño allow that warm, expanded water to pile up against the west coast instead of being pushed westward across the Pacific the way it typically would in a normal year. Put those two effects together, and you get a temporary but very real bump in coastal sea level. And researchers presenting at that town hall put the estimate at roughly 6 inches of additional sea level rise along the California coast this year, specifically because of El Niño. Here's why that number is more serious than it sounds in isolation. That 6-inch bump doesn't exist by itself. It stacks directly on top of the sea level rise California has already experienced from long-term climate change, which, depending on exactly where you are along the coastline, ranges from roughly 6 inches to nearly a full foot accumulated over the past century alone. Add those two effects together, and communities up and down the California coast are looking at total sea levels this winter that could be a foot or more higher than what would have been considered a completely normal baseline just a generation ago. And all of that elevated water is arriving during the exact same months when the state's biggest winter storms typically hit. Researchers from the Scripps Institution of Oceanography have presented detailed modeling specifically illustrating the increased likelihood of high wave events tied to this pattern. And the mechanism is intuitive once you hear it explained. Higher baseline sea levels mean that even a completely routine winter storm surge, the kind that wouldn't normally make headlines, now reaches meaningfully further inland. It pushes seawater into storm drains, low-lying neighborhoods, and infrastructure that would have comfortably handled the exact same wave energy under normal conditions in a normal year. That's the underlying mechanism behind the kind of dramatic coastal flooding and wave damage that made headlines during past strong El Niño winters. And this year's elevated starting point is pushing that risk into genuinely new territory for a lot of coastal communities that haven't had to think about it in years. Now, here's the part where the scientists are actually being the most careful, and understanding why reveals something genuinely important about how the science itself has evolved over the past couple of decades. For a long time, the working assumption for most people in California was simple. A strong El Niño automatically equals a wet winter, full stop. The reality that researchers have been emphatic about clarifying recently is considerably more nuanced than that old rule of thumb. The mere existence of a super El Niño does not guarantee a parade of atmospheric rivers, those narrow concentrated bands of tropical moisture, responsible for a huge share of California's rainfall and its most damaging flood events. An event this strong is expected to meaningfully shift the odds in favor of a wetter than average winter, especially across Southern California and likely Northern California as well. But shifting the odds is fundamentally different from a guarantee. And researchers at Scripps have separately pointed out that the statistical relationship between ocean conditions and actual rainfall totals has noticeably weakened over the current century compared to earlier decades. That's a genuinely unexpected wrinkle, and it's forcing scientists to broaden their forecasts to account for a wider range of possible outcomes instead of confidently predicting a single, straightforward wet winter the way older, simpler models used to. That uncertainty is not a reason for reassurance, and researchers have been careful to frame it exactly that way rather than letting anyone off the hook. The 2015 and 2016 Godzilla El Niño remains the clearest cautionary tale here. It ranked among the strongest events ever measured in raw ocean temperature, and yet it largely failed to deliver the dramatic rainfall increase across Northern California that comparisons to 1997 and 98 had led people to expect. What it did produce instead was a genuinely serious, if less anticipated, hazard. Record-breaking beach erosion up and down the California coastline, driven by the exact same combination of elevated sea levels and intensified wave energy that scientists are now flagging as close to a near certainty for this year's event, regardless of how the rainfall forecast ultimately plays out. In other words, even in a scenario where the anticipated deluge of atmospheric rivers doesn't fully materialize the way some might hope or fear, the coastal flooding and erosion risk tied directly to sea level and wave physics remains a serious, largely unavoidable threat that's already baked into the ocean physics of this specific event. There's also a marine ecosystem disruption already showing up as this El Niño builds, and it reaches well beyond simple weather impacts into the coastal economy and food chain directly. El Niño disrupts the cold, nutrient-rich upwelling that normally sustains California's coastal marine ecosystem. And researchers who study the coast, including marine biologists based at universities along the California coastline, have described the resulting shift bluntly, calling it essentially a completely different ocean. Species like squid, anchovies, and sardines get pushed considerably further north than usual, as the cold upwelling that normally concentrates them along the California coast weakens. Previous strong El Niño events have coincided with documented appearances of hammerhead, tiger, and bull sharks in California waters, species far more associated with warmer tropical conditions than California's typical coastal ecosystem. Past strong events have also produced serious, well-documented harm to native seabird and marine mammal populations, including elevated numbers of stranded fur seals and large numbers of dead seabirds washing ashore along the west coast during the 2015 to 2016 event specifically, casualties of an ecosystem suddenly starved of the cold, nutrient-dense water its entire food chain depends on. It's worth understanding how the mechanics of El Niño actually travel from the middle of the Pacific Ocean all the way to California in the first place, because the connection isn't as simple as warm water somehow directly causing rain thousands of miles away. El Niño's warming reshapes atmospheric circulation on a genuinely global scale. It weakens the trade winds that normally blow steadily from east to west across the equatorial Pacific. And critically, it shifts the position of the Pacific jet stream, the high-altitude river of fast-moving air that steers storm systems across the entire west coast. Under normal conditions, the jet stream tends to sit further north, often directing the bulk of incoming Pacific storm energy toward the Pacific Northwest instead of California. During a strong El Niño, the jet stream typically shifts southward, aiming more directly at California in the southwest. And that southward shift is the fundamental mechanism behind the storms and flooding rains that a significant El Niño can potentially deliver. The genuine complexity researchers are still working through is exactly how reliably that southward shift translates into actual accumulated rainfall once it arrives, since the same broad pattern shift can still produce meaningfully different outcomes on the ground, depending on exactly how individual storm systems track, cluster, or fail to fully materialize within that generally favorable setup. The financial stakes tied to this developing event are genuinely staggering once you zoom out to the global scale, even before you get to California's specific coastal risks. Some economic analyses have floated the possibility that this El Niño could become the costliest on record, with early estimates suggesting global financial losses could run into the trillions of dollars once you account for disrupted monsoon rainfall across Asia, shifting precipitation patterns across South America, altered hurricane formation across both the Atlantic and Pacific basins, and closer to home, the specific combination of coastal flooding, erosion, and infrastructure strain that California emergency planners are now racing to prepare for. Numbers at that scale should always be treated with some caution, since early economic projections tied to a still developing weather pattern carry a lot of built-in uncertainty. But even conservative estimates put this among the most economically significant El Niño events in the modern record, which tells you something about how seriously institutional planners are taking it. And that seriousness is already visibly showing up across California, months before winter has even started, which offers a genuinely useful window into how differently officials are treating this forecast compared to a routine seasonal outlook. In San Diego, the city has convened a dedicated working group bringing together representatives from every relevant city department specifically to prepare for the range of weather-related emergencies this winter could bring. Officials there have specifically flagged the need to closely monitor creeks, rivers, and reservoirs throughout the region, given that the city's stormwater infrastructure includes aging systems and century-old dams that weren't necessarily engineered with a compounding, climate-amplified El Niño event in mind. Further north, footage from the coast in late July already showed city crews building sand berms specifically to guard against flooding from high tides and strong surf, precautionary construction undertaken weeks before the El Niño pattern had even fully locked into place. That's a genuinely visible sign that coastal California isn't waiting for winter to arrive before it starts preparing. Beyond that, one city's coordinated response, similar preparation efforts have quietly been underway across coastal jurisdictions, the length of the state, from harbor authorities reviewing dock and breakwater infrastructure to county emergency managers, updating flood evacuation planning for low-lying neighborhoods that haven't seen serious inundation risks since the last strong El Niño winter. Insurance industry analysts have also begun flagging this developing event as a genuine planning concern, given that California's coastal property insurance market was already under significant strain heading into this year following several consecutive years of wildfire-driven losses. That means a winter of serious coastal flooding and erosion damage would be arriving at a moment when the state's insurance infrastructure has comparatively little slack left to absorb another major category of climate-driven loss on top of everything that's already strained it. It's also worth stepping back to understand why researchers keep returning to this specific combination of factors: record ocean temperatures, a warmer global baseline than any previous El Niño has ever formed against, and a weakening, less predictable relationship between ocean warmth and actual local rainfall as evidence that this event genuinely represents uncharted territory rather than simply being a bigger version of a pattern California has weathered several times before. Super El Niño events themselves remain genuinely rare. As of this year, there have only been a small handful documented in the full recorded history of ocean temperature monitoring, And researchers studying long-term sea surface temperature variability have found some evidence suggesting these extreme events may be becoming somewhat more frequent as natural ocean variability plays out against the backdrop of a warming planet, though the underlying science connecting long-term climate change directly to El Niño frequency remains an active, still developing area of research rather than a fully settled scientific conclusion. At least one atmospheric scientist who has studied this specific question closely has urged genuine caution about overinterpreting exactly what a record-breaking event like this one means for the years that follow it, noting plainly that with only a handful of comparable Super El Niño events on record globally, the statistical foundation for confidently predicting long-term consequences remains genuinely limited. Scientists making projections based on such a small historical sample, he's argued, shouldn't claim excessive confidence about whether an event like this triggers a longer, multi-year stretch of amplified global impacts, or whether its effects turn out to be considerably more contained to the single year or two immediately following the event itself. That's a genuinely important, honest caveat, sitting underneath all of the more dramatic warnings in this story. It's a reminder that even the scientists most convinced this event is historically significant are being careful not to overstate exactly how far its consequences will ultimately extend. And that kind of intellectual honesty is exactly what you want to see from the people whose job it is to get this right. So, pulling all of this together, what should residents across California actually take away from watching a Super El Niño develop in territory that has genuinely never appeared in 75 years of careful record keeping? The clearest, most consistently repeated message across every briefing and every official statement covered here is that the physical mechanisms driving coastal risk, elevated sea levels stacking directly on top of existing long-term sea level rise, and intensified wave energy layered on top of that already elevated baseline are close to a near certainty this winter, regardless of exactly how the broader rainfall forecast ultimately plays out. The rainfall question carries genuine, honest uncertainty, shaped by a relationship between ocean temperature and actual local precipitation that has become measurably less predictable in recent decades. But the coastal flooding, erosion, and infrastructure strain tied directly to sea level and wave physics represents a threat that California communities are already actively preparing for, precisely because the underlying ocean physics driving it doesn't carry nearly the same level of forecasting uncertainty that rainfall totals do. That's the real picture behind this developing Super El Niño, a climate pattern confirmed to be pushing into territory that has never once appeared in 75 years of careful, instrument-based record keeping, arriving on top of a planet that is already running warmer than at any point in recorded history, and threatening California's coastline with a combination of elevated seas and intensified waves that scientists describe as close to guaranteed, layered on top of a rainfall forecast that remains genuinely uncertain in exactly the ways that matter most for flood planning. Nearly 6,000 people logged on to a single online meeting to hear scientists explain this in plain terms, because on some level, they already understood that this wasn't a routine seasonal update. And if you've made it this far, you probably understand that too. It's also worth remembering that California isn't the only place watching this pattern build, even if it's the region getting most of the attention in this video. The same shift in the jet stream and global atmospheric circulation that's expected to steer storms toward the west coast this winter also reshapes weather patterns across the entire globe. And researchers are already tracking early signs of disrupted monsoon behavior in parts of Asia, shifting rainfall belts across South America, and altered hurricane formation patterns in both the Atlantic and Pacific basins. None of those stories get the same coverage that California's coastline gets, largely because California's combination of dense coastal population, aging flood infrastructure, and fire-scarred hillsides makes it one of the more visibly vulnerable places on the planet when a pattern like this fully locks in. But it's a useful reminder that what's unfolding in the tropical Pacific right now isn't a California story that happens to have global side effects. It's a global story that happens to hit California particularly hard for reasons rooted in geography as much as anything else. That geography matters more than people often realize. California's coastline sits almost perfectly positioned to catch the brunt of a southward shifted jet stream. Its hillsides are still recovering from consecutive years of destructive wildfires that stripped vegetation and destabilized soil in exactly the kind of terrain that turns heavy rain into dangerous debris flows. And its stormwater and flood control systems in many coastal cities were engineered decades ago under a completely different set of assumptions about sea level and storm intensity than the ones playing out today. Layer a record-breaking El Niño on top of that existing vulnerability, and you start to understand why officials aren't waiting for confirmation before acting. They're treating the current forecast as the working assumption, not a worst-case scenario to be dismissed if it doesn't fully materialize. The honest truth is that nobody, not NOAA, not the researchers at Scripps, not the climate scientists who've spent their entire careers studying California's most extreme weather, can tell you with certainty exactly how many storms are going to hit this winter or exactly how much rain is going to fall in your specific neighborhood. What they can tell you, with a level of confidence that's genuinely rare in this field, is that the ocean is already higher than it should be, that it's going to get higher still before winter arrives, and that the waves riding on top of that elevated water are going to hit harder than they have in years. That's not speculation. That's physics that's already unfolding in real time along a coastline that 6,000 people cared enough to tune in and hear about directly from the scientists tracking it. So here's the real question, worth sitting with as this story keeps developing over the coming months. If the ocean is already breaking 75 years of recorded history months before the first real winter storm is even formed, what exactly happens when that storm finally does arrive on top of it? Nobody has a fully confident answer to that yet, and honestly, that uncertainty is exactly what makes the next few months worth watching closely rather than tuning out. We'll be tracking every new update from NOAA and from California's own climate researchers as this record-setting event continues developing through the fall and into winter. Because this is exactly the kind of story where the difference between being genuinely prepared and being caught completely off guard could come down to the weeks right in front of us. If today's breakdown helped make sense of what's actually happening out there in the Pacific, stick around, because we're not done tracking this one, not even close.